Again, Apache Ambari is a fantastic tool. I've kind of tracked this tool over the last few years, and it does a great job in terms of setting up your Hortonworks cluster and setting up Kerberos, so on and so forth. So as many of you see on the screen, it kind of gives you a very systems view of the world. How much CPU is being used, what is the cluster load, so on and so forth. And you can also kind of look at things around heat maps, which hosts are being used to do things around configuration settings, so on and so forth. But when it comes to really understanding how your applications are doing, Apache Ambari does only so much, and rightfully so, because it's been built to address the systems management issues around it. So let's kind of take a look at it. If you go and click on the Yarn sort of link and you look at the Resource Manager UI, it kind of takes you to the Resource Manager page. And as I kind of pointed out, in many cases, a lot of customers don't even have access to the Resource Manager web UI, because from here you can pretty much access to all the nodes. So here you can just take a look at all the Thales applications that are running or the Spark applications that are running. So it kind of gives you a high-level view of what the applications are doing, and then just clicking on any of these applications takes you to the next level of view, right? So this view just kind of gives you a high-level summary. But if your Spark job is failing or not working optimally, you need to be spending a lot of time on these web UI and have a good understanding how to reason about the different sort of counters and numbers out here to understand what to tune and what to optimize. Similarly, if you go and look at the Spark web UI, there are some, I think we've run some Spark applications here. So it kind of, the Spark web UI gives you, again, a high-level view of how the applications are performing, and then clicking on a given application, you can start to get into the next level of detail. And then you can start kind of like clicking through the various interfaces to really understand how the application is running, and so on and so forth. But eventually, you need to get to the logs to really understand what to tune and optimize, right? Even the Spark web UI doesn't tell you what to fix or what to address. It kind of gives you a lot of good information, and even we use that information, but you have to make sense out of it. And that's the problem, because the big data infrastructure is shifting really fast. There are new distributed systems that are coming in. So we cannot expect everyone to be up to date in terms of all of these changes and new frameworks that are coming in. So it becomes very difficult for operators and also the end users to rationalize and argue about the performance of their big data applications. So in contrast, let me kind of show you. So hopefully this kind of like gave you a gist of many of you on this webinar are already using Ambari. So you're kind of familiar with what Ambari does, and you're also kind of familiar in terms of looking at the Spark web UI and the logs to understand the application performance. In contrast, when you come to Unravel, as I kind of mentioned early on, we're taking a very application top-down perspective of how your applications are doing. So this is the entry point at Unravel, where you can come in and look at all the applications that are running in the cluster. You can search by various dimensions. We support like everything from MapReduce to Hive to Impala to Spark, and recently we added support for Thales and Kafka. So we have all the support for the major distributed systems out there, and you can slice and dice by various dimensions to understand how these applications are doing. So this kind of gives you an easy way for both the end users to come in and understand just the jobs by a particular user, or even the operators can come in and understand, hey, like at this particular time in the night, let me understand which jobs are not working, and let me start troubleshooting those applications. Let's kind of double click on the Spark application that was failing, and let's kind of figure out what's going on. So I can just look at all the Spark applications that are failing and then click on any of these applications to understand what's going on. So let's look at one of these examples where I have a Spark application that an end user ran and it failed. So today the chances are you have to go and look at Ambari. From there, click on the Spark web UI, go and look at the Yarn page, and then from there to the Spark web UI page, look at the failing application, then spend a good amount of time chasing down this problem in terms of why this application failed. In contrast, if you look at Unravel, we kind of give you everything related to the application in one view. We're kind of showing you the program that was submitted along with that application. And then we kind of telling you, okay, this is what happened. The application ran for 1 minute, 25 minutes, 1 minute, 25 seconds, and then it kind of failed. And frankly, you don't have to do much. If you just click on the events page here, we kind of telling you, we are summarizing that information that the executors have failed with Java out of memory exception, right? And if you click on the errors tab out here, we're kind of giving you the fatal exception around that these executors, executor 4 has got a Java out of memory or the Java heap size issue, right? So we are pretty much summarizing what you would have taken like a few hours. We're summarizing all of this information in a few clicks, and then you can now collaborate with the operations team and say, hey, can we increase the memory requirements around it? And for some of you who might be like wanting some more proofs, Unravel kind of provides you all the bells and whistles. So you can actually come in and say, okay, let me really understand like what really happened from these executor perspective. I can look at for each of these executors, how much memory is being used, and I can also look at like I can look at the VM RSS and really understand that like some of these executors are requiring memory of around like 2.2 gig. But if I go and look at my conf and the configuration, and if I look at the memory settings, the executors have been allocated only 2 gigs of memory. So clearly there's a mismatch here where we've asked for 2 gigs, but these applications are exceeding the memory requirements, causing like Java out of memory sort of heap size issues. So very easy with Unravel to really understand the failure issues. But more importantly, with Unravel, we do a lot of the legwork behind the scenes and then give you in plain English what the problems are and how we can go about fixing those. So hopefully this makes sense, like in terms of how we can improve the productivity and reduce the MTTR for many of these applications that could be running in production. Let's take a look at another example where we can talk about performance improvement, right? And here's an example of a Spark job that ran in the cluster, and it ran in 13 minutes, 59 seconds, and the end user would like to figure out what they can do to speed it up, right? And this is just an example, but in many cases, we've seen Spark applications run for a few hours, and end users are like, why is this application taking so long? And with Unravel, it becomes very easy to see that, hey, there are many tasks. Maybe there are certain tasks that are affected by skew, and they're crunching more data than others. That could result in why this particular job is slowed down, because it's just this particular task or few tasks that are stragglers. So with Unravel, we help you really answer this question: why is my app slow? Right? Today, like with your existing tooling, it's a very open-ended problem. Like many times, people don't even know where to start to answer those questions. So with Unravel, you can come in and say, okay, great, I know like this application took 13 minutes, 59 seconds. The important thing to keep in mind with Unravel is that we try to give you everything related to the application in one view. And that's important. We say, can we provide a 360-degree view of the application? And instead of you kind of looking at like all the different web UIs, we bring all the related information, important information from the app perspective and present you in a way that becomes easy to understand. So you can look at the key KPIs, you can understand the program that you submitted along with it, you can also understand how many tasks it created, you can look at some detailed resource usage metrics at the container level. This is something unique to Unravel, where we've created a sensor technology that really understands how resources are being used within the container level and then feed that to Unravel. Now you can also understand how many Spark stages were created, understand, get an idea of the Gantt chart view, which tells you how time was being spent. The first step of optimizing is figuring out where the bottleneck is, so you can optimize that particular stage. You can also look at the query plan. You can also look at like the errors, as I kind of mentioned, so on and so forth. So from here, you can actually click on any of the stages that is of interest to you and drill down into the next level of detail, and we kind of tell you what happened within that stage. So notice how we started off with the highest level of abstraction, that is your application, and then from there you can start drilling down all the way to understanding how these particular tasks ran on the host. Excuse me, ran on the underlying host. So we kind of give you all the information from the application drilling down to the underlying host where it's running, and that's why we say with Unravel, we provide you a full stack perspective of what happened from the application perspective. But again, in this case, if you didn't have the time and you really wanted to kind of quickly figure out what is that you can do to improve performance, you can just click on the orange bar at the top, and we kind of tell you, we give you the recommendation straight up, right? Like just looking at this tab, you can quickly figure out that in this case, obviously dynamic allocation was not turned on. So we figured out that you were just getting 2 executor instances. You're much better off by changing the number of executor instances to 9. You can also change your Spark executor overhead memory and increase the level of default parallelism. So for each of this, we have certain heuristics and models that are running as part of our software in your environment, right? So Unravel is deployed on your environment, sitting on the edge node. It is observing everything in the cluster. So as this application is running, it is getting an X-ray view of this application, but it is also understanding what else is happening in the cluster at that time. And based on those parameters that feed into our machine learning models, we're able to kind of tell you what is your current state and what is your recommended state. What should be your future state to get more performance for this application? Because clearly we have observed that, and you can increase the amount of parallelism based on the number of executors that are available in the cluster and what else is happening in the cluster. We also kind of give you, so we not only give you these recommendations, but we also kind of tell you the science behind it. We kind of tell you why is that we are asking you to make these changes. For some of you, for especially the developers, you would like to understand like why is Unravel suggesting these in the first places. So we kind of tell you the reason behind it. And many times, obviously, since we have these sensors running, we can also understand how resources were being used or underused. A lot of times we've seen like people are asking for default container size, or they're using default settings that Ambari came up with. But then you realize these executors are not using all the resources, so you can cut down the memory requirements asked by these executors. So the Unravel recommendations are not only at the configuration level, we also kind of give you recommendation in terms of are there certain RDDs you can cache to improve performance, right? So this is a good example where we have said that there is an opportunity for you to cache an RDD, and that can potentially save you 3 minutes of this particular application. And if you look at the program view, we kind of tell you like what line of code you can go and change so if you look at the recommendation again, we're kind of giving you a high level view in terms of what RDD you can change or optimize by adding a cache statement. And that's what we have done. So I took these recommendations that Unravel provided. I've added a persist statement to the line of code, and I'll kind of show you the line of code. And then I reran the same application, which now ran in 2 minutes. So significant performance improvement from 13 minutes to 2 minutes. And that's the reality. There are a lot of these moving parts, there are a lot of knobs. It becomes extremely difficult for somebody to manually track this and do this. But with Unravel, we kind of provide you an automated way to help you figure out what to do that. So if you go and look at this line, so here's where we've added the persist statement to cache a certain RDD. So helping you link from the program perspective to what really happened from the execution perspective, and then keeping track of the RDDs that can be cached to improve performance. So Unravel kind of gives you a very holistic perspective in what are the different knobs and what are the different levers we can pull to improve the performance of your Spark application. So hopefully this kind of give you a good sort of a few examples on debugging failed applications, speeding up Spark applications. Let me also kind of show you around Taze. So Taze is the new is a new framework. We've added support for many of the Hortonworks customers who are running their Hive on Taze jobs or Pig on Taze jobs. So one thing you'll kind of notice is, again, even for Taze applications, the look and feel is very similar to what you saw in your Spark applications or Hive application. We kind of tell you, we present everything related to the Taze application in one view. Then I can click on the particular DAG. It kind of gets me to the next level of detail. I can look at the graph. I can look at all the appropriate counters. I can look at all the vertices associated with that. And then everything related to this particular DAG is presented here. And in this case, I'm also kind of giving you recommendations. What is that you can do to improve performance? So we're kind of constantly adding. So one of the value props of Unravel is that as we're learning from our customer environment, we try to figure out what these use cases are and the common use cases that can be improved by changing a certain tuning parameters, and we go ahead and build those models in our product and then make it available to our customers to run it in their environment. So as these corner cases or these performance challenges creep up, Unravel can effectively help point those issues and then give the right recommendations. So let me kind of switch gears right now and also kind of talk about like the workflows, right? So I kind of talked about individual applications around Spark or looking at Hive, or you can look at like Tails applications. But the other big value add of Unravel is that like we not only support ad hoc applications, we also help you figure out what is really happening from a data pipeline perspective, right? So I think this is important as many of you are putting like different systems together. You have a data pipeline that runs from Kafka to Spark to HBase or back to like Kafka, or you're scoping it out to other systems. You really want to understand how your end-to-end data pipeline is doing, where it's really a collection of jobs that are coming together that's orchestrated using Oozie or AutoSys or Airflow. And with Unravel, in Unravel, we provide out-of-the-box support for many of these scheduling engines. So you could use any of these scheduling engines to orchestrate your data pipelines, but with Unravel, we'll be able to kind of show you end-to-end how the data pipeline is doing. So in this case, we're kind of telling you how a particular data pipeline is performing. And then if you just look at like within Unravel, you can clearly see how time is being spent, which component is taking the most amount of time. So in this case, it had 2 MapReduce components and 1 Spark job. We clearly are kind of telling you this particular MapReduce job ending with 0584 took the longest amount of time, and we are baselining this job, right? Since this data pipeline runs regularly, we are able to on the right panel, we are able to kind of figure out like what is the deviation in performance daily, and then we can compute the average and tell you this current run, how is it deviating from the baseline, and we can send you the appropriate alerts. So this is a classic case of if you're missing the SLA, what happens, right? So with Unravel, we send you an alert saying that you're going to miss the SLA, and when you come to Unravel, you get to see why did it miss the SLA, which component took the most amount of time that it deviated from the baseline. And then with Unravel, so now we can also click on each of these components and then get through the next level of detail, similar to what we have done, and we can start kind of drilling down into the performance of that particular specific components. But with Unravel, we also kind of like do a lot of the work behind the scenes, where we are really understanding what is happening from this data pipeline perspective, and then giving you a guided path to figure out why this SLA was missed. And in this case, like we're kind of pointing out that like this particular workflow, the problem with this particular workflow was that this particular MapReduce job, which you saw, was not getting the right resources in the cluster. And so it's really a function of what was happening at the cluster at that time, whether instances where there were other jobs that were stealing resources in the cluster, and it could be, right? Many times, like we've seen, the problem has got nothing to do with the application. There could be other rogue jobs that could be eating up resources in the cluster. So in this case, this particular data pipeline was affected because there were other jobs that were running in the cluster. And then if you go now to the operations view of the world, we kind of tell you, you can look at it, you can look at the cluster from a forensic perspective and understand what jobs or application were running at a given point in time. So if you look at the right panel, we've created a bunch of alerts here. And if you look at it, like right at the time 2150, when we ran that workflow or that particular MapReduce component ran, we detected there was a rogue application that was detected. And if I just click on this rogue application, it kind of takes me to the cluster view of the world. And right here, like it just tells me what happened in the cluster overall. And from a forensic view, it kind of tells me, look, this particular MapReduce component, if you remember, I said was ending in 0584. At that time, there was a Spark shell application that was running that was kind of taking up all the resources in the cluster. Notice the amount of allocated MB that the Spark shell was running. So Unravel kind of like did the detective work, but more importantly, we've created the policies in Unravel to be able to detect these issues. And here we're kind of pointing out there was an auto action triggered. Now, auto action is a policy that you define in Unravel to figure out all of these outlier cases, and then you can, once the policy is specified, it gets triggered when these cases happen, and then we can do different things around it. Like if you give Unravel the right permission, we can go and kill that Spark application or move it to a different queue, or or just send you an alert so that you can act on it. So this way, it helps the operations team to be a lot more proactive, and then you can also ensure that the SLA on their workflows are successfully met. And here's a quick preview on the the auto actions capability, as I kind of mentioned. So there are a whole bunch of like auto actions that we have created in the product, and these are just different policies you can create. But we also have a very powerful policy engine that we have built. So you can create interesting policies above and beyond what we provide. So we provide you 10 or so use cases or policies out of the box, but you can extend it to any other that may need your that may fit your environment, and you can send alerts based on that. And the entire product is also built on a REST API, so you can take these alerts, feed it to Nagios or PagerDuty, feed it to Slack within your organization, and it just creates a closed loop feedback system where you can understand how applications impact of the applications on the cluster, and then proactively take actions to mitigate those to ensure the performance of your key applications.